This is Lecture 4, Theory Building. By the end of this lecture, you should be able to formulate an argument, write a hypothesis, and draw a graph illustrating the hypothetical relationship between two variables. Now that you know how to collect, measure, and describe variables using simple statistics, I'm going to start teaching you how to engage in the scientific process in political science research. Recall that in the very first step of the scientific process, we choose a specific outcome of interest to focus on. This outcome of interest is called the dependent variable. It's called a variable because we examine cases where the outcome varies. For example, when we study voting behavior, we examine cases where people vote for Republicans and when people vote for Democrats. Next, recall that in the second step of the scientific process, we identify one factor that influences our dependent variable. That factor is called the independent variable. Then we build a theory or model to explain how the independent variable affects the dependent variable. All well-written theories or models clearly identify what the dependent and independent variables are. They also clearly identify how the independent variable affects the dependent variable and also explain why the independent variable affects the dependent variable that way. In the first part of this lecture, I'm going to show you some examples of well-written models and poorly written models. Here is an example of a model. In this study, we focus on explaining why some House candidates use party symbols while running for office, while others do not. We argue that personal level factors such as gender influence how candidates use party symbols. What is the dependent variable? Use of party symbols while running for office is the dependent variable, as it is the outcome of interest the authors are trying to explain. What is the independent variable? Gender is, as gender affects the use of party symbols in House elections. An easy way to identify which factor is the independent variable and which factor is the dependent variable is to draw a diagram like this and place the names of the variables here and here with an arrow between them. The independent variable will always influence the dependent variable, not the other way around. Now, how does gender affect the use of party symbols? Are men more likely to use them or women? We cannot tell from this paragraph, since we do not know how gender affects the use of party symbols in House races. This is a poorly written model. Here's another model. This article analyzes the use of vetoes in presidential systems. We argue that landmark legislation is more likely to be vetoed than non-landmark legislation. What is the dependent variable? The use of vetoes in presidential systems, as it is the outcome of interest the authors are focusing on. What is the independent variable? Landmark or non-landmark legislation, as the type of legislation influences the use of vetoes. How does the independent variable influence the dependent variable? Landmark legislation is more likely to be vetoed than non-landmark legislation. So we know how landmark legislation influences vetoes, but do we know why? We cannot tell from this model. Hence, it is a poorly written model. And here's another model. In this paper, we investigate the impact of cell phone technology on violent collective action. We argue that availability of cell phones allows political groups to overcome collective action problems more easily and coordination issues. Utilizing data on cell phone coverage and the location of organized violent events in Africa, we're able to show that the availability of cell phone coverage significantly and substantively increases the probability of violent conflict. What is the dependent variable? Use of violent collective action, as it is the outcome the authors care about. What is the independent variable? Cell phone technology, as it influences whether violent collective action takes place. How does the independent variable influence the dependent variable? As access to cell phones increase, the use of violent collective action increases. Why does the independent variable influence the dependent variable that way? Cell phones allow groups to overcome collective action problems and coordination issues when they are organizing collective violence. As you can see, this is a well-written model. After reading it, you can identify the dependent and independent variables. You can also explain how the independent variable influences the dependent variable and why the independent variable influences the dependent variable that way. Please note that while this is a well-written theory, most well-written theories tend to be pages long. When you write a theory or a model, you should explain in great detail how and why your independent variable should influence your dependent variable. Next, recall that the third step in the scientific process is to derive hypotheses from our models. Recall that a hypothesis is a one-sentence statement we derive from our model. It tells us how variations in our independent variable lead to variations in our dependent variable. The hypothesis should be testable or observable in the real world, meaning that we should be able to collect data to determine if the hypothesis correctly identifies the relationship between our independent and dependent variables in the real world. After you write your model, if you cannot write a hypothesis based on the model, it probably means you need to rewrite your model. There are several different ways to write hypotheses. I'm going to discuss a few templates you can use to write your hypotheses. You can use the more likely than, less likely than template. It is generally useful when you have dichotomous independent and dependent variables. Dichotomous means that the variable only has two categories or values. Here is a good example of how we can apply the more likely than, less likely than template. The independent variable gender is dichotomous as it only has two categories, women/men, and the dependent variable party identification is also dichotomous as it only has two categories, Democrat and Republican. Using this template, we can write the following hypothesis. Women are more likely than men to identify as Democrats. Note that this hypothesis illustrates how variations in the independent variable, women versus men, influence variation in the dependent variable, Democrat versus Republican. Women are more likely than men to identify as Democrats versus identifying with Republicans. You can also use the more than, less than template. It is generally useful when we have a dichotomous independent variable and a continuous dependent variable. Here's a good example of how we can apply the more than, less than template. The independent variable type of institutions is dichotomous because it only has two categories, democracy and dictatorship. And the dependent variable defense spending is continuous because it can take on any value between 0 and a positive value. In this example, we could use a template to write the following hypothesis. Dictatorships allocate more resources to defense spending than democracies. Note that in this example, our hypothesis includes information how variations in the independent variable, dictatorship/democracy, leads to variations in the dependent variable, more spending versus less spending for democracies. You can also use the independent variable increases/decreases, dependent variable increases/decreases template. This template is generally useful when you have continuous independent and dependent variables. In this example, both defense spending and per capita income are continuous variables as they can take on any value between 0 and a positive number. Using this template, you could write the following hypothesis. As the per capita income of a country increases, the amount of resources the government spends on defense increases. Note that this hypothesis identifies how variations in the independent variable per capita income increases lead to variations in the dependent variable, defense spending increases. Here are some common mistakes when writing hypotheses. The first poorly written hypothesis states, some countries are more likely to go to war than others are. The hypothesis does not indicate how variations in the independent variable lead to variations in the dependent variable. Some countries are more likely to go to war than others, but which countries? What factor influences whether a country goes to war? In the corrected version of the hypothesis, it is clear that political institutions influence whether a country goes to war. Dictatorships are more likely to go to war with other countries than democracies. The second poorly written hypothesis states, wealthy countries have high standards of living. In this hypothesis, there is no variation in the dependent or independent variables. With respect to the independent variable, wealth of a country, the hypothesis only focuses on wealthy countries and does not reference poor ones. With respect to the dependent variable standard of living, the hypothesis only focuses on countries with high standards of living and does not reference countries with low standards of living. Based on this hypothesis, it is unclear what we expect to happen in poor countries. Do they have low standards of living or high standards of living? To write about their hypothesis, we could write, wealthy countries have higher standards of living than poor countries. Now we know that we expect poor countries to have lower standards of living. If you want to know if you wrote an appropriate hypothesis, you can draw a graph of the relationship between your independent and dependent variables. If you cannot draw the graph, it means you need to rewrite your hypothesis. In order to draw the graph, you draw a y-axis and label it with the dependent variable name, and an x-axis and label it with the independent variable name. Place the appropriate values on the axes and draw a line illustrating the relationship between the two variables. Here is an example of how to draw a graph based on a hypothesis. Consider the following hypothesis. As the per capita income of a country increases, the amount of resources the government spends on defense increases. The dependent variable in this hypothesis is defense spending. It can range from 0 to billions of dollars. The independent variable in this hypothesis is per capita income. It can also range from 0 to about $60,000. This is what a graph of this relationship would look like. The dependent variable defense spending is on the y-axis, and the independent variable per capita income is on the x-axis. Each axis is labeled with appropriate numerical values. And since our hypothesis suggests that as per capita income increases, defense spending increases, we should draw a line with a positive slope on this graph to illustrate that as per capita income increases, defense spending increases. Note that even if your hypothesis allows you to draw a graph of the hypothetical relationship between your two variables, that only means that your hypothesis tells you how your independent variable influences your dependent variable. It does not tell you why your independent variable influences your dependent variable that way. There are many different types of relationship between independent and dependent variables. The one we just focused on was linear, meaning that as our independent variable increases, our dependent variable increases or decreases at a constant rate. As you can see in this slide, this is a positive linear relationship between the independent and dependent variables. As x increases, y increases at a constant rate. As you can see in this slide, this is a negative linear relationship between x and y. As x increases, y decreases at a constant rate. And in this graph, there is no relationship between x and y. As x increases, y stays the same. There can also be nonlinear relationships between our independent and dependent variables, with logged relationships. As the independent variable increases, the dependent variable either increases or decreases, but at a non-constant rate. This graph is an example of a positive logged relationship. At low values of x, as x increases, y increases a great deal. But at higher values of x, as x increases, y only increases a small amount. Last, this is an example of a parabolic relationship. When the relationship between an independent and dependent variable is parabolic, the relationship between the independent variable and dependent variable at lower values of the independent variable is the opposite of what it is at higher values of the independent variable. So in this example, there is a negative relationship between x and y at lower values of x, but there is a positive relationship between x and y at higher values of x.